Wow.
Welcome to the world of chemistry. It's once again my joy to welcome you to this channel. In today's video, we want to define oxidation and reduction in simple tabular form that is going to be precise and coincide with the right definition of oxidation and reduction. Of course, I know different work have been done in defining oxidation and reduction, but in this video, we are going to present it in tabular form, such that during the examination, it will be very easy for you to remember and for you to put down. Therefore, redox reaction. Redox is from the two reactions, that is red for reduction and us from oxidation. Therefore, today we are defining redox reaction, that is oxidation and reduction. Oxidation and reduction in terms of oxygen, hydrogen, in terms of oxidation number, and in terms of electron transfer in a simple tabular form, like I've said, so as for you to be able to remember easily in examination. Yes. In terms of oxygen, what we call oxidation. Oxidation is simply the addition of oxygen to a substance. Addition of oxygen to a substance. For example, you have copper atom reacting with oxygen to give you copper 2 oxide. Balancing that equation, put 2 moles of copper and 2 moles of copper 2 oxide being formed. Any reaction whatsoever, once you see addition of oxygen in such a reaction, they will revert to such equation or such reaction as oxidation reaction. As well, what is reduction? Reduction is the removal of oxygen from a substance. This same compound, if you have copper, for example, copper oxide, that is copper 2 oxide, that way to remove oxygen from that. It is to form this in solid state, that in gaseous state, this in gaseous state. All right? Now, removing oxygen from copper 2 oxide to give you copper and oxygen is what you call reduction. Therefore, removal of oxygen from a substance is called oxygen. In terms of hydrogen, removal of hydrogen from a substance is what you call oxidation. Removal of hydrogen from a substance is what you call oxidation. Let's look at this equation as well. H2L, that is hydrogen sulfide, precisely 2 moles of hydrogen sulfide reacting with up gas. From there, balancing this, we say removal of hydrogen from a substance is equal to oxidation. Therefore, what we are going to get there is sulfur plus water. Yes, let's try to balance that equation. We have 3 atoms of sulfur, so making 3 moles there. 4 atoms of hydrogen, making 4 atoms of hydrogen, and 2 atoms of oxygen, 2 atoms of oxygen. This is balanced. All right, looking at this is hydrogen sulfide. There is hydrogen and sulfur together, hydrogen sulfide. But this, at the product side, you have sulfur and water being formed. So in a simple term, we will just say hydrogen sulfide has been oxidized to sulfur and water. Removal of hydrogen from a substance is what we call oxidation. So, other way around, addition a substance is what we call reduction. Addition of hydrogen to a substance is what we call reduction. For example, hydrogen plus chlorine gas, that is hydrogen gas plus chlorine gas, to give you hydrochloric acid gas. All right, two atoms, 2 moles of hydrochloric acid. Here, hydrogen is being added to chlorine. Addition of hydrogen to a substance is reduction, which means you will read this equation as reduction of chlorine give 2 moles of hydrochloric acid. That is, in terms of hydrogen, removal of hydrogen from a substance is reduction. Yes, let's move for now to in terms of electron, leaving out this one for now. In terms of electron transfer, the loss of electron is what we call oxidation, loss of electron. For example, sodium atom or sodium metal, losing an electron, that is losing 1 electron in its atomic shell, will give you sodium ion. Sodium has only 1 electron in the atomic shell, valence electron, and that is why it's in group 1. Now, losing that 1 electron will make it to become a sodium ion. In balancing that equation, that means plus electron. So, sodium here has been oxidized to sodium ion. Sodium atom or sodium metal is oxidized to sodium ion. That is lost electron to become sodium ion. Yes, on the other hand, acceptance or gain of electron is what we call reduction. Acceptance or gain of electron is what we call reduction. So I can have an equation like this, maybe copper 2 ion, okay, to give me copper atom. Something must have happened. This one, by the time it gains 2 electrons, then it becomes a metal. Acceptance of electron is what we call reduction. That is acceptance of electron. This one is loss of electron. It's called oxidation. Acceptance of electron or gain of electron is what we call reduction. Yes, back to in terms of oxidation number. In our last class, we've discussed what oxidation number is and the rules to follow in assigning oxidation number to any atom or compound or substance in a reaction. If you still remember, one of the rules says any unbounded atom has oxidation state of 0. That is, if an atom is standing alone, is not in a compound, then the oxidation state of such is equal to 0. Oxidation state of oxygen, except in peroxide, is -2. Oxidation state of hydrogen, except in peroxide, is +1. And so on like that. Yes. Therefore, now we define oxidation as increase in oxidation number. Increase in oxidation number. Yes, you can pick any of this one as an example. Let me pick this as my example in doing that. Oxygen to give me CO. Okay, if I balance it, notwithstanding, it remains, yes. This is copper, irrespective of the number of moles. Copper is standing alone. Copper is alone here. Therefore, its oxidation state is 0. Oxidation state, let me put here oxidation number or oxidation state. Oxidation state of copper here is 0. Oxidation state of oxygen here is 0. Even though it's diatomic, it's just oxygen. It's an atom, it's a mole of oxygen. It is just oxygen. Therefore, standing alone, its oxidation state is 0. Now, coming here, if you remember in our last class, we calculated how we oxide. We said this is a compound that is not charged. Therefore, its oxidation state is equal to 0. We are looking for the oxidation state of copper and copper 2 oxide. Okay? That means this is X plus, from our last class, oxidation state of oxygen is -2. That is the valence of oxygen there. Okay, doing this very well, we have X minus 2 is equal to 0. And doing that from our mathematics, we say X is equal to 2. And that is why this is called copper 2 oxide. The oxidation state of copper here is 2. Therefore, this is plus 2. Oxidation state of oxygen is -2. Yes, we said increase in oxidation number. Increase in oxidation number is what we call oxidation. Therefore, from here, oxidation state of copper moves from 0 to 2. That is an increase. An increase. Oxidation state moves from 0 to 2. So increase in oxidation state is oxidation. That means we say copper is oxidized to copper 2 oxide. Copper atom or copper metal is oxidized to copper 2 oxide. Yes, let's look at from oxygen here, standing alone, to oxygen in copper 2 oxide. Yes, from 0 to -2, that is a reduction. Therefore, when such happens, you will say oxygen is reduced, that is decrease in oxidation number or oxidation state of atom is called reduction. Decrease in oxidation state of an atom is called reduction. So oxygen moves from 0 to -2, that is decrease. So we say oxygen has been reduced. Yes, going back to this table, it will be very easy in examination or before examination. If you sit down with this table and you study it properly, it will be very easy for you to be able to define your oxidation and reduction, even at a glance. In terms of oxygen, oxidation is addition of oxygen to a substance. In terms of hydrogen, oxidation is removal of hydrogen from a substance. Increase in oxidation number is oxidation. And loss of electron is oxidation. Coming to reduction. Reduction is the decrease in removal of oxygen from a substance, addition of hydrogen to a substance, decrease in oxidation state, and loss of electron is gain of electron is reduction. If you have a blank question that says define oxidation and reduction, or let's define oxidation, it's not specified either in terms of oxygen, in terms of, it's just define oxidation. All you just do is you try to put the three together to form a sentence, and you say oxidation is the addition of oxygen to a substance, removal of hydrogen from a substance, increase in oxidation number, and loss of electron. And likewise, to reduction, you do that. Yes. So the other aspect of today's video, how to identify oxidizing agent and reducing agent. That is so simple. Any substance that is reduced is the oxidizing agent. And any substance that is oxidized is the reducing agent. I say that one again. Any substance that is oxidized is the reducing agent. Any substance that is reduced is the oxidizing agent. Yes, coming back to this equation as an example, we said copper is oxidized. That is moving from 0 to 2, therefore, is the reducing agent. Copper is the reducing agent in this equation. Yes, coming back here, oxygen is reduced. Therefore, oxygen in this equation is the oxidizing agent. So when you are given any equation and you are able to identify which one is oxidized, which one is reduced, anyone that is oxidized is your reducing agent. Anyone that is reduced is your oxidizing agent. Yes, in our next video, we are going to be balancing redox reaction. That is how we've gone as far as to know how to calculate the oxidation state of different atoms in a compound. Like a copper oxide, we said this is a compound that is not charged. Therefore, its oxidation state is equal to 0. We are looking for the oxidation state of copper in copper 2 oxide. Okay, that means this is X plus, from our last class, oxidation state of oxygen is -2. That is the valency of oxygen there. Okay, doing this very well, we have X minus 2 is equal to 0. And doing that from our mathematics, we say X is equal to 2. And that is why this is called copper 2 oxide. The oxidation state of copper here is 2. Therefore, this is plus 2. Oxidation state of oxygen is -2. Yes, we said increase in oxidation number. Increase in oxidation number is what we call oxidation. Therefore, from here, oxidation state of copper moves from 0 to 2. That is an increase. An increase. Oxidation state move from 0 to 2. So increase in oxidation state is oxidation. That means we say copper is oxidized to copper 2 oxide. Copper atom or copper metal is oxidized to copper 2 oxide. Yes, let's look at from oxygen here, standing alone, to oxygen in copper 2 oxide. Yes, from 0 to -2, that is a reduction. Therefore, when such happens, you will say oxygen is reduced, that is decrease in oxidation number, or oxidation state of an atom is called reduction. Decrease in oxidation state of an atom is called reduction. So oxygen moves from 0 to -2, that is decrease. So we say oxygen has been reduced. Yes, going back to this table, it will be very easy in examination or before examination. If you sit down with this table and you study it properly, it will be very easy for you to be able to define your oxidation and reduction, even at a glance. In terms of oxygen, oxidation is addition of oxygen to a substance. In terms of hydrogen, oxidation is removal of hydrogen from a substance. Increase in oxidation number is oxidation, and loss of electron is oxidation. Coming to reduction, reduction is the decrease in or removal of oxygen from a substance, addition of hydrogen to a substance, decrease in oxidation state, and loss of electron is gain of electron is reduction. If you have a blank question that says define oxidation and reduction, or let's define oxidation, it's not specified either in terms of oxygen, in terms of, it's just define oxidation. All you just do is you try to put the three together to form a sentence, and you say oxidation is the addition of oxygen to a substance, removal of hydrogen from a substance, increase in oxidation number, and loss of electron. And likewise, to reduction, you do that. Yes, to the other aspect of today's video, how to identify oxidizing agent and reducing agent. That is so simple. Any substance that is reduced is the oxidizing agent, and any substance that is oxidized is the reducing agent. I said that one again. Any substance that is oxidized is the reducing agent. Any substance that is reduced is the oxidizing agent. Yes, coming back to this equation as an example, we said copper is oxidized. That is moving from 0 to 2, therefore is the reducing agent. Copper is the reducing agent in this equation. Yes, coming back here, oxygen is reduced. Therefore, oxygen in this equation is the oxidizing agent. So when you are given any equation and you are able to identify which one is oxidized, which one is reduced, anyone that is oxidized is your reducing agent. Anyone that is reduced is your oxidizing agent. Yes, in our next video, we are going to see redox reaction. That is, we will balance oxidizing, reducing reaction, balancing the half cell and the overall reaction. Thank you.
If you found this video educative, Please like, comment, share, and subscribe. Thank you.